Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics, Paper 4.3 for October-November 2024, Part 2 for questions from 5 to 7. Question 5. A particle of mass 12 kilograms is going to be pulled across a rough horizontal plane by a light inextensible string. The string is at an angle of 30 degrees above the plane and has tension T newtons. The coefficient of friction between the particle and the plane is 0.5, but given that the particle is on the point of moving, find the value of T. Since the particle is on the verge of moving, then we can put this frictional force that acts directly opposite to the direction of motion. Now we need to resolve this force here. So we are going to close it in, and closing is cosine. So T, if you have been following in the previous videos, so closing we call it cos, and then opening will be sine. So I'm trying to put the forces acting on this particle. We shall have here T sine of 30. But then there is also normal reaction because this particle is on horizontal plane, so there is this normal reaction. We shall have 12g. There is 12g, that is the weight of the particle that acts downwards. Okay, so now resolving forces vertically, we can see that R plus T sine of 30 is equal to 12g. So this therefore implies that R is going to be equal to 12g. That will be 120, then minus a half of T, because sine of 30 is a half. Then horizontally, resolving these forces, we are going to have T cos of theta. There is mu R, which is equal to T cos of 30 degrees. Okay, so mu is given as 0.5. Our R is 120 minus a half of T. Then cos of 30 is root 3 over 2, then times T. So we open the brackets. A half of 120 is 60. A half over half is a quarter, is equal to root 3 over 2t. Then I will leave here the 60, and then I will take a quarter of t this side, so that it finds this root of 3 over 2t. Then I can factorize because I want the value of t. So I can have a quarter, then plus root of 3 or 2 of t, which is equal to 60. So that means t is going to be 60 divided by a quarter plus root of 3 over 2. So putting this one in the calculator, we can have 60 out of 1 over 4, then plus root of 3 over 2. It's 53.76, and the rest of those figures, but the three significant figures, this will be 58. 53.8 newtons. Part B, given instead that the particle is accelerating at 0.2 meters per second squared, find the value of T. Now here we are going to use F is equal to ma. Okay, the force that is taking this one forward is T cos theta. Then we subtract the one that is opposing the motion. You get this minus this, so that will be the net force, the net driving force. So this one is going to be T cos of 30 degrees minus mu of R is equal to ma. Then of course this will be root of 3 over 2 of T minus mu is 0.5 r is 20 minus t over 2, or a half of t. Then the mass is 12. Is it 12? Let's check up here. Yes, the mass is 12. Then times the acceleration is given as 0.2. So again, we open the brackets, root of 3 over 2 of t minus, this will be 60, then plus the t over 4, which is going to be equal to 12 times 0.2, that will be 2.4. Now, root of 3 over 2 plus a quarter, then we factorize out the t, then we shall get 2.4 plus 60. So meaning t is going to be equal to 62.4. Then we divide by root of 3 over 2 plus a quarter. What does this one give us? Get your calculator. 62.4. Then we divide by root of 3 out of 2 and then plus a quarter. So the three significant figures, this one will give us 55.9. So we write 55.9 newtons. Question 6. A particle moves in a straight line. It starts from rest at t is equal to 0 and accelerates at 0.6 t meters per second squared for 4 seconds. Now we are given the expression for acceleration. So meaning here we are not going to use the equations of motion. The v is equal to u plus at, s is equal to ut plus a half at squared, and then v squared is equal to u squared plus 2as. Instead, here we use differentiation and integration, because here we are having variable acceleration. For the other three, the acceleration is constant. Okay. Reaching a speed of v, the particle then travels at v meters per second for 11 seconds and finally slows down with constant deceleration, stopping after a further 5 seconds. Now, we know that acceleration is equal to the rate of change of velocity. Okay, so we are supposed to show that v is equal to 4.8. So this simply implies that v is equal to the integral of a dt. So we are going to integrate. We are moving from 0 to 4 because they say that it starts from rest at t is equal to 0 and accelerates at this for 4 seconds. So from 0 to 4. See that? And then another thing we are going to have is now put the expression which is 0.6t and then with respect to t. So this one is going to give us, increase the power by 1 divided by the new power, that is 0.3 t squared. Then you put 4, 0. So 0.3 times 4 squared, then minus, of course, 0. So when you just put this one here in the calculator, 0.3 times 4 squared, you get 4.8. So 4.8 meters per second. Then part B, sketch the velocity time graph for the motion. Now, since we have gotten our expression for v as 0.3 t squared, again the expression is 0.3 t squared. Let's say when we integrated here and we didn't have the limits, we would have put plus c. But since the particle was starting from rest, that means that t is equal to 0, v is 0. So even the c would be 0. You see that? Okay, so this therefore implies that our v, let me write something down here. Our v is equal to 0.3 t squared. This is a quadratic expression. So this is a U-shaped curve, a U-shaped quadratic curve, because you can see that the coefficient of t squared is a positive, so that is U-shaped. Now, Let's come to the sketch here. Just do something like that. Then I can put this one here like that. Then we have time in seconds. Then here we can have velocity in meters per second. Now, at t is equal to 4, and say this is 4. Then we are having this 4.8. The v is 4.8. So since this one is a U-shaped curve, it is quadratic. So I'm going to have something like this. Then I draw a U-shaped curve. It must look like a U, okay? Then let's go back to the question. They said that reaching a speed of v, accelerates for 4 seconds. Then the particle then travels at v meters per second for 11 seconds. So when you get 11 plus 4, you get 15, okay? We get 15. So we get 11 plus the 4. That means here we shall have 15. And this one has to be a straight line, okay? It's traveling at this speed here. Then after that, we are going to have, what else are they saying? They are saying that, and finally slows down with constant deceleration, stopping after 5 seconds. So 5 plus 15, we get 20. So I can make 20 here, and then I draw a straight line there. Now, I think to be accurate, let me just use a straight line here. Something like that. Even here, let me take this off, and then we can use a straight line just like that. So that is going to be our graph there. Part C, find an expression in terms of t for the velocity of the particle for 15 to 20. 15 to 20, we have seen that it is a straight line. So we need to find the equation of that straight line. Now, the equation of this straight line, this one is 15 and then 4.8. You see that? Then this other one here is 20, 0. Now, for deceleration is the same as negative gradient. So, we can have our gradient of this line. The gradient is going to be equal to the change in y. If we can check again, the change in y is this one here, which is 4.8. And then the change in x here, or the change in velocity, is 4.8. The change in time is 5. Now, we are going to now have 4.8 divided by 5. But we shall put a negative because the line is slanting like that. These ones have negative gradient. If the line is like that, we have positive gradient. Okay, then after that, we are now going to have our v. So what is this one? Simplified. We have negative 4.8 divided by 5. That is negative 0.96. So this simply implies that v is going to be equal to negative 0.96 of t. Okay, we don't know where it is cutting the y-axis, I mean the velocity axis. In other words, we are using this y is equal to mx plus c, the general equation of a straight line. Now, I'm using this coordinate 15, 4.8. This one here, okay, I can use this or this one, any of them. Okay. Now, v is 4.8, negative 0.96, t is 15. So what will be c? Our c is going to be the 4.8, then plus 0.96 multiplied by 15. So let's check that one out. 4.8 plus 0.96 of 15. And that is 19.2. So this C is 19.2. That means the expression for velocity is going to be negative 0.96 of t, then plus 19.2. This is what we are having here. Then part D, find the total distance traveled by the particle. So for velocity time graph, you should know that total distance, the total distance is equal to total area under the graph, total area under the graph, Now, when we go to our graph here, you can see that this one is a curve. So I'm going to integrate from 0 to 4, the expression we have here. Then I can also, this one is just a trapezium, so we can get the area of a trapezium, okay? As simple as that. So I can have now this one giving me the area from 0 now to 4. We integrate 0.3 t squared with respect to t, and then we add area of a trapezium is a half h, so the h is 4.8. Then our a is this one here, which is 15 minus 4, 11, and then the b is from here up to here, 20 minus 4, that will be 16. Okay, then I'll have my a as my height as 4.8, then my a as 11, and then the other one is 16. When we integrate, we increase the power by 1, and then we divide by that power. So 0.3 divided by 3, that will be 0.1, then t cubed. So from 0 to 4, then plus, this will be 2.4 into 27. So this will be 0.4, sorry, this will be 0.1, then times 4 cubed, of course minus 0, then plus 2.4 times 27, that will give us 64.8. Now, all of this put in the calculator, 0.1 times 4 cubed is 64. So 4 cubed. Then after that, we can add 64.8. Then this one will give us 71.2. So the answer is 71.2 meters. Question 7. Two particles A and B of masses 3 kilograms and 5 kilograms respectively are connected by a light inextensible string that passes over a smooth fixed pulley. The particles are held with a string taut and its straight parts vertical. Particle A is 1 meter above the horizontal plane and particle B is 2 meters above the plane. The particles are released from rest. In the subsequent motion, A does not reach the pulley, and after B reaches the plane, it remains in contact with the plane. Part A, find the tension in the string and the time taken for B to reach the plane. Now we need to identify the forces that are acting on these particles. So A has a mass of 3 kilograms, then it will have weight 3g acting downwards, and then here there will be tension acting upwards. And that same tension will also be here because it is the same string that passes over the pulley and then connects to B. Then this one here will have 5g as the weight. So, of course, the bigger one, the heavier one, is the one that is going to move downwards. So we are going to have this one accelerating downwards, and then this one here will accelerate upwards. You see that? Now, of course, there is also that tension there. It is the same that is pulling the pulley down. So we are going to use our F, which is equal to MA. Okay. F is equal to MA. Now let's look at the forces that are acting on particle A. So we have, since it is going up, then the tension is bigger than the weight. So we shall have T minus 3G, then is equal to mass is 3 times A. And then the ones that are acting on B, since B is moving down, that means the weight is bigger than the tension. So that will be 5G, then minus the T, which is equal to 5A. To eliminate T, I can just add, you see, so that this one disappears. One is minus, the other one is positive. Then 5G minus 3G, that will be 2G, which is equivalent to 8 of A. That means acceleration is going to be 2 times 10 out of 8. 20 over 8, that one gives us 2.5. Okay. This one will give us 2.5 meters per second squared. Now they want the tension, so we find the tension using any of the equations. So T is going to be equal to 3G, which G is 10, then times 3 of A, which is 2.5. Okay, and then our tension is going to be, let's check it out here, that is 30, then plus 3 into 2.5. So that is 37.5 newtons. That will be the tension in the string. Now, using S is equal to UT plus a half AT squared, because remember they have told us to find the time taken for B to reach the pulley. The time taken, we know the distance it is going to travel. It is 2 meters. B is 2 meters. B is 2 meters from the ground here. So now we are going to substitute here, and we say that this is 2 meters. Since the system is released from rest, so we have 0 here and then a half, then times the acceleration we have gotten as 2.5, and then now T squared. So we can cross multiply, you will get 4 here, which is equal to 2.5 of T squared. So meaning T is going to be equal to the square root of 4 over 2.5. So 4 divided by 2.5, square root of 4 divided by 2.5. That is 2 root 10 over 5, which can be to 3 significant figures, 1.26. 1.26 seconds. Part B, find the time for which A is at least 3.25 meters above the plane. Find the time for which A is at least 3.25 meters. Meters above the plane. Now, when B reaches the plane, A is 3 meters above the plane. Let me take you back here. Okay? When B reaches the plane, because now B has covered 2 meters by the time it is here. Now A has also moved 2 meters up. Do you see that? Now add on this one here, so it is 3 meters above the plane. And at this point, the string becomes slack. Because B has reached here, this one becomes slack. So we assume the tension in the string is now 0. Okay? Now, if the tension in the string is 0, that simply implies that we are going to get a new acceleration. But now, these are the scenarios we are going to have. We need to find the speed with which B moves, with which B hits the ground here. That will be the same distance, the same speed A will be moving with when it has covered also these 2 meters here. Okay? Now, this same speed is going to be the initial for the final movement. Okay? So let us find the speed. Let me write something here. When B reaches the plane, A is 3 meters above the plane. Okay, at this point, the string becomes slack, and the tension in it is 0. Now we need to find the speed. Finding the speed with which B hits the ground. Okay, that is what we are going to find here. So using v squared, which is equal to u squared plus 2as, so our final velocity is going to be, since the system is released from rest, so we are going to have 0 squared here. Then 2, the acceleration, we got it as 2.5. Then the distance traveled is 2. Okay, then 4 times 2.5, that is 10. So this is square root of 10 meters per second. Now this one here, this is the same speed for A. Okay, now time taken to cover a distance of 2.5, that is what we found, because they said when it is at least, okay, at least 3.5 meters. So let me draw some small sketch here. I have my A is now 3 meters above the ground. Okay, now it is going to move a distance here of 0.25, because they said when it is at least 3.25 meters above the plane. So we need to find, and of course it will go, let's say this is the 0.25, it will go reach a maximum and then we'll come back. So here also, so the time we are looking for is here, to move from here to here, and also now to move from here up to here. This time is the same because this is symmetrical, so it is going to be 2 times. Okay, so if this is T1, then this is T2. When I get T2, I can just subtract T1 to get the time that is taken here. Okay, now using S, which is equal to UT, okay, plus a half AT squared. What are we even finding here? So here we are finding time taken, okay, to cover, time taken to cover a distance of 0.25. Now the distance here is 0.25, which is equal to u. Now the initial velocity for the movement here is going to be the other root of 10 we have gotten. Okay, so root of 10t, then plus a half, okay, times, since this is vertical motion, now the acceleration, because remember this one is now moving vertically upwards, it's like free fall or free movement under gravity. So we are going to have now the acceleration for that movement is going to be the one due to gravity. It's no longer this 2.5. Okay, it was this 2.5 when the tension was still there. Now the tension is not there. I hope you get the difference. Okay, now this is a half. Since it is moving up, then the tension is negative, and then it is squared. So if I bring this one this side, it will be 5t squared, then minus root of 10t, and then plus 0.25, which is equal to 0. This is a quadratic equation, so I can solve it. T is equal to negative. Please always show the examiner that you are solving the equation. Don't just put everything in the calculator there and then you leave it out, so you lose a mark. So minus b plus or minus to the root of b squared, then minus 4ac, 0.25, then out of 2a, so 2 times 5. Then you can now put this in the calculator. So inside the brackets, let me just square that 10, root of 10, you'll get 10, then minus 4 times 5 times 0.25, we shall get 5. Okay, so we have here root of 10 and then plus or minus root of 5, then out of 10. Okay, so that means my T1, okay, my T1 is going to be root of 10 plus root of 5 over 10. And then my T2 is going to be root of 10 minus root of 5 over 10. So the difference is the one that gives us the time when the particle is at least 3.25 meters above the plane. So we shall have the difference here is going to be root of 10 plus root of 5 over 10. Then subtract root of 10 minus root of 5 over 10. So like that. So then what do we get here? We are going to have root of 10 plus root of 5. Then down we have 10. Then we say minus root of 10 minus root, need to space here, then minus root of 5, then over 10. So it will give us root of 5 over 5. And then to 3 significant figures, what does it give us? 0.447. This is 0.447 seconds to 3 significant figures, like that. So this has been it for this part of the paper. Thank you so much for watching. If you find the content very helpful to you, kindly give us a thumbs up. All right. See you in the next videos. Please like, share, and even subscribe.